Welcome to our lesson on the chemical properties and chemical changes. This is 5.3 in your textbook, and just like our previous lesson, we're covering two main topics here, the first of which is chemical properties, and the second of which is chemical changes. So let's get into chemical properties first. In our previous lesson, we talked about physical properties. Now, physical properties talked about a substance as is. So without changing anything about that particular object or substance, we can describe it. Chemical properties are a little bit different. We are describing how that substance acts or how it behaves as it's reacting with other things around it. So it is a characteristic of a substance that is determined when the composition of that substance is changed and one or more new substances are produced. We are looking at an object and seeing what happens when it interacts with other chemicals. We are describing what is happening as it's changing. So here are a few examples of chemical properties. So say we have a substance A, and we are seeing how toxic it is. So if it has a very high toxicity, we can describe it as being very reactive with certain parts of our bodies, right? That's what we call toxic. That would be a chemical property. Or flammability. So if it comes into contact with oxygen, it can burst into flames. That would be flammable. So we would be describing its chemical property. Lastly, we've got chemical stability, which just refers to how stable or how reactive a substance is. Again, we're referring to how this particular substance is interacting with other chemicals around it. Now that was pretty short, but that's all you need to know for chemical properties. We're going to spend most of our time talking about chemical changes, which is our next main topic here. Now, chemical changes refers to a change that is accompanied by a change in the starting object or starting substance to a new substance. What I mean by that is that there is a new substance being formed. If you think back to physical changes, we were talking about things like ice melting and paper being folded, right? We weren't actually creating or producing new substances. In a chemical change, new substances are formed. However, it's important for you to realize that the original substance does not always disappear. Instead, the components of that original substance are rearranging themselves so that a new substance is created. Now, we won't look into that in a whole lot of detail, but that's essentially what chemistry is. We're looking at how things can change under different circumstances. Now, one of the big questions that we're going to be looking at in grade 9 science, specifically in chemistry, is how do we know if a chemical change has occurred? How do we know if a new substance is produced or not? Because we can observe certain things, we can observe certain reactions, but there's only so much that we know. We have 5 indications that a chemical change could have happened. So we're going to go through 5 main things that can happen when we observe a reaction, and that can be clues that can tell us if a new substance is formed. So the first evidence of a chemical change is a change in color. So a new substance is formed that has a different color than the original substance. So this is often true with food. You might notice that when you cook a food, say for example eggs, there is a slight change in color from before you cooked it and after you cooked it. Another example would be meat or fish. If we're cooking some of those things, there's a change in color, and that change in color is what tells us that that food is now edible, that we can actually eat it and it'll taste good, right? Because a chemical change has happened and a new substance is formed. The second evidence of a chemical change, again related to food, would be a change in odor. So a new substance has formed that has a detectable odor. An example here, if you have cookie dough, before you put it into the oven, it might look like this. And then as it's cooking, you might notice a certain smell. This might be true for anything that you're baking or cooking. If you notice a new smell, that is a huge indication that a new substance has formed. So you know that when you're getting that cookie, that it is edible because it's no longer the same as the cookie dough that you put into your oven. It's a completely new substance, which is an indication that the chemical change has occurred. The third of which of the evidence of a chemical change are bubbles. And if you see bubbles, most likely than not, it means that there is a gas produced. So let's look at a video that'll show you this in a more obvious way. So this is the baking soda and vinegar experiment. So there's baking soda off to the left there. There's some vinegar and some food coloring as well, although this reaction will happen exactly the same if the food color wasn't there. It just wouldn't be pink. So if you mix those two substances together, you'll notice that there's a lot of bubbles being formed, and that's what's sort of pushing up over there. Those bubbles are the presence of a gas. In this particular case, the gas is carbon dioxide. But anytime there's a gas produced, you'll see bubbles, and that's an indication that a new substance has been formed. Now the fourth one, this is probably the hardest for you to understand because it's less common in our daily lives and more common in a lab setting. So this fourth evidence of a chemical change is that a new solid is seen. Now it's very important that I tell you that just because a solid is formed doesn't mean that it fulfills this criteria of a new substance. It has to be two liquids that are mixing to form a solid. So when two liquids are mixed and a solid is produced, the solids that are formed in this way are often powdery and are called precipitate. Now the precipitate, the powder that's formed, the solid that's formed, that is our evidence of a chemical change. So just because you have a solid and a liquid and you still have solid at the end of that reaction, that doesn't mean that a new substance has been formed. So let's take a look at a video that shows this. So you've got a liquid there, and she's pouring it into a graduated cylinder. So that's our first liquid. Our second is in this particular bottle, and she's going to take some and mix them together. So as she's pouring the liquid drop by drop into the graduated cylinder, you'll notice that a white substance is being formed. Those were two liquids that were mixed together to form this solid. This white solid is what we call the precipitate. So if you have two liquids mixing together and a solid is produced, then you have a precipitate, which is this evidence of a chemical change. So again, it has to be two liquids. Moving on. The last of the 5 evidences is that there's a change in temperature or a change in light. So in this case, when you have a reaction, energy is released or absorbed, and you can detect that as a change in temperature or a change in light. So we'll see which of those two we're going to see in this particular reaction. I'm just going to fast forward here. Right, so there has been mixtures there. He put some water in there, so a reaction is taking place. Now, other than a change in temperature and light, there's another indication that we're seeing here. which is our change in color, right? So we have our purple color, which is being produced. There's a change in color, which means that there's already a chemical, we already know that there's a chemical change, but we're about to see the light there, right? So we've seen the energy that's being released, the fire there. That's our indication that there is a change in temperature or light. Now, this is quite intense, and unfortunately, we're not going to be doing something this exciting in our labs. What we might notice is that sometimes when you are using a test tube and you put in two different chemicals in there, and if you touch that test tube, it might feel a little bit warm. That's the extent to which we might be experiencing a change in temperature or light in our labs. So this is sort of an extreme example, but still very, very valuable in understanding this evidence. Other examples of chemical changes, I mentioned earlier cooking, right? So cooking cookies, baking in the oven, really good example of a chemical change. And then we've got rusting of iron as well. That's also a chemical change. Try and think to yourself, which of those 5 criteria are being met for you to know that that is a chemical change. Now, this is another video. I'm not going to play it for you, but it goes through the process of baking a cookie and talks about all 5 criteria of it being a chemical change. So maybe if you're interested, it is linked on the PowerPoint, so you can watch that through there. And that was it for our lesson. For homework, you're doing questions 3 and 4 in section 5.3.